A marshmallow moving at the speed of light should be impossible. But imagine looking up at the sky and discovering that one is racing toward Earth right now. Not an asteroid, not a comet, a marshmallow. And somehow, that tiny fluffy snack could become one of the most destructive objects our planet has ever seen. Sounds ridiculous, right? But here's the strange part. The science gets terrifying very quickly. A normal marshmallow is mostly sugar, water, gelatin, and tiny pockets of trapped air. Harmless, soft, lightweight. So how could something like that become a planetary threat? The answer starts with speed. Light travels at nearly 300,000 kilometers every second. That's fast enough to circle Earth more than 7 times in a single second. And according to everything we know about physics, no ordinary object should ever reach that speed. The faster something moves, the more energy it requires. Push it far enough, and the energy demand becomes effectively infinite. Game over. Except in this scenario, the impossible has already happened. Now picture a marshmallow drifting outside the International Space Station. The vacuum of space begins pulling it apart. Its trapped air expands. The marshmallow swells larger and larger. Then suddenly, it accelerates. Faster, 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 until it's moving at 99.9% the speed of light. At that velocity, the trip from orbit to Earth takes less than a millisecond. Almost no warning. Almost no time to react. But that's not even the craziest part. Because the real danger isn't what the marshmallow starts as. It's what it becomes during the fall. And that's when things changed. As the marshmallow plunges into Earth's atmosphere, something unbelievable happens. Every atom in the air becomes a collision. At normal speeds, air feels harmless. At near light speed, air becomes a wall. And this is where it gets weird. Atmospheric particles don't simply bounce off the marshmallow. They slam directly into it. Some become embedded inside it. The marshmallow actually starts gaining mass while falling. Think about that. The closer it gets to Earth, the heavier and more dangerous it becomes. But what happens next changes everything. The impacts generate unimaginable heat. Temperatures rise instantly. The fluffy exterior begins tearing apart. Explosions erupt around it. Shockwaves spread through the atmosphere. For a moment, this sounds like good news. If the marshmallow breaks apart, much of its energy gets released before reaching the ground. Humanity might survive. But what if it doesn't? What if part of it remains intact? Now the story takes a dark turn. The intense heat transforms the marshmallow itself. The soft white candy disappears. The carbon inside begins hardening, darkening, changing. By the time it reaches the lower atmosphere, it no longer resembles a dessert. It's becoming something closer to a high-speed graphite projectile, a meteor made from candy. And here's the twist nobody expects. The object that started as one of the softest things imaginable is now behaving like one of the hardest. The question is no longer whether it survives the fall. The question is what happens if it reaches the ground. And the answer is far worse than most people would guess. Imagine standing in a major city when the impact finally happens. The sky flashes. A shockwave races outward. Windows shatter instantly. Buildings tremble. And all of it was caused by a marshmallow. But here's the strange part. The destruction isn't coming from the marshmallow itself. It's coming from its speed. Even relatively small objects become devastating when enough energy is packed into them. History already gave us a warning. In 2013, the Chelyabinsk meteor exploded over Russia. Thousands of buildings were damaged. More than 1,000 people were injured. And that object wasn't moving anywhere near the speed we're discussing. Now scale the danger upward. A near-light speed marshmallow could release several times more energy than that famous event. The exact damage would depend on where it landed. An ocean impact could trigger massive waves. A remote region could be devastated locally. A direct strike on a densely populated city could be catastrophic. Millions of lives could be at risk, all from something usually roasted over a campfire. That's the paradox. The softest object becomes deadly when physics pushes it beyond ordinary limits. But that raises an even bigger mystery. If a marshmallow can become this dangerous simply because of speed, what about everything else? A baseball? A bicycle? A turkey? At what point does an everyday object stop being ordinary and become a world-ending weapon? And if speed can transform a marshmallow into a disaster, what other impossible threats are hiding